Okay, so let's get started. Once again, this meeting is being recorded. And we have only one item on the agenda, which is to review one of the SWAT team work item. If you have anything that you want to discuss, feel free to add to it.
What are we cutting? Release.
Okay. 1.0 June snapshot release. Okay. Let's talk about that first. This should be quick. We'll just follow the regular monthly release policy. So the first release candidate will be cut on 14th, and we will try to stabilize it in a week. And if everything goes well, we expect to release it by around 20th. If not, we will probably cut a new release candidate on 21st.
June 21st?
June, yeah.
June 10 days.
Any other questions, Fran? Okay. Any questions about the release? If not, we'll move on to a design review. So I think most of you should be aware that we started this SWAT team effort this quarter. We are actually working on a lot of different things in parallel, but this is one of the deliverables, which is to analyze the existing test cases and probably enforce test categorization, because the tests we have today are not properly categorized, and as a result, it's not easy to just do go tests and run order tests in the source tree. So Jimmy and I have been working on this for a while, and we actually took it a little bit further and implemented a extensible test analysis tool. So it's not just for test categorization, but it can be used for a lot of other purposes. So I think I talked a little bit about the problem statement. So the biggest problem is that right now we have very little visibility into test quality in general. So recently we shipped 0.80, but we went through a month-long code orange, and even in the last minute, we had some surprise when we realized some important features was not implemented in the new V1 Alpha 3 API. And it was not caught because the corresponding test had been disabled. And even the owners didn't realize that until the last minute. And the other problem is that Go test did not run out of the box. There were actually some integration tests that required additional setup, and they were mixed into the unit test today. So just running Go test / in top level could just fail. And even make test failed in my experience, but it apparently had been fixed recently. So I tried it again last week and it seemed to work, but Go test doesn't really work that well. Does anyone else have anything to add to the problems with testing today? Okay. So here are the goals and requirements that we have identified. The number one is from Louis' testing principles doc, that tests must be explicitly categorized into appropriate buckets that represent the complexity of their environments. Categorization is the responsibility of the development team and must be obvious. Right? So we are trying to define some simple rules so that people can follow, and we can build some automation to enforce it. So that's why the second goal is to define test bucket rules that are straightforward, non-intrusive, and easy to follow. Right? We are not trying to implement any heavy-handed process, but we just want something that is easy to follow and allow tooling and automation to be implemented for enforcement. Right? So we are implementing an extensible tool that can analyze Go files and allow custom analytic rules to be implemented easily and quickly. And the tool can be used in different contexts as well, right? It can be used in linter, or it can be used in a cron job for reporting, or it can be used for any other purposes. Is more or less a generic framework that can be plugged in. It also supports waitlisting mechanism to allow exceptions with approvals. For whatever reason, if certain rules should not apply to some files, they can be waitlisted. So the primary focus is on the Go files in Istio repositories, where most developers contribute to. We haven't heard as many problems in Istio proxy in the C++ code, so that is not the focus now. So in terms of the design, this checker is the analytic tool that we are implementing. And basically it takes our source code, like the Istio source tree, and jumping ahead. So it basically takes a list of directory paths and recursively scans for Go files. And then it builds abstract syntax trees for the out of the Go files and run through a bunch of rules to analyze the Go file. And at the end, it produces a report. So it's a fairly straightforward process, but the rules are pluggable in the sense that different applications can plug in different rules, and different rules can apply to different files, right? And
are we using an existing tool as a basis for this, or are we writing this from scratch?
It's basically from scratch.
Okay. Did you look at existing tools that do similar things?
We actually want something. So this is actually very straightforward, first of all, and the implementation is simple, and it allows us to implement our custom check very easily. So I haven't.
But there's a lot of tools out there that analyze Go source code, right?
Right, but
so
to be able
to plug into one of those.
But in order to plug in different rules, I haven't seen anything that allows a straightforward interface to be plugged in that way. So there are ways to build abstraction index trees and then write code to do whatever you want.
Right.
But so this is built on top of the abstraction index tree library.
Okay.
Right? We are not building our own abstraction index tree, if that's not what you're talking about. But this is just we define a bunch of interface to abstract it out, and so that people can just implement a rule, and the framework can just pick it up and go through and process the syntax.
None of the existing like linter things that we've been looking at are extensible in the way we need.
Right, because we actually want to use it not just as linters.
Right. But I just mean that like there's not existing libraries that can do.
Right. We actually look at the linter as well. Some existing linter support, but because the checks that we want is not as simple as like regex.
Right.
So it's actually easier to write code to do the check that we need.
Okay.
But other than that, I haven't been able to find anything that is similar to the framework that we are trying to build here. So as I mentioned earlier, the design is pluggable. So different applications can actually implement different rules for different analytic requirements. The check function is the main entry point. It takes a list of file paths, a rules factory, and a whitelist, and a report. I'll explain all those below. So basically, the rules factory and the whitelist are extension points where the coder or the application can configure what rules should apply to different files. And the application implements the rule interface and provide the actual logic to produce diagnostic information using an abstract syntax tree built from the Go file. Each rule is expected to run just one specific check. Potentially, it can even query external system and make sure the information in the Go file conform to certain standards. And multiple rules can be implemented for different checks against the same tree. So this is the rule interface. Basically, each rule is identified by an ID, and it performs one particular check on top of an abstract syntax tree node. And the rule factory is the interface to provide the mapping from file path to the corresponding rules. And it allows a fine-grained control over what rules should apply to what files. Basically, as an example, the test file can use a different set of rules from regular Go files, or a mix of files can have different rules from pilot files. The interface is fairly straightforward. It just returns a bunch of rules given a file path. And then in addition to rules factory, application can also provide a whitelist to opt out selected files from certain rules, and this allowed temporary disablement until some file is updated to comply with the rules, or it can be used as an exception mechanism so that people can explicitly approve certain files to break some rules. And the whitelist object is basically backed by the map from string to string slice. The keys are the file path, and the values are just the rule IDs. And then the report is a utility used to accumulate all the diagnostic information for final consumption. When a rule runs a check, it can add information to the report using the helper functions. And basically, it can provide file location information and diagnostic message. So the eventual message will actually show which Go file at which line is reporting a particular message. And then after all the checks are done, the items helper function can be used to retrieve all the formatted text-based report. Right, so there are a number of different example use cases. So the first one is that the checker can actually go through all the test functions in all the _test.go files and create a warning if a test is being skipped without having a GitHub issue assigned. Right. So this goes back to the first example in my problem statement. We don't even know what tests are being skipped. So having a check like this will allow us to properly check all the skip tests and make sure they are restored when the underlying issues are fixed. And the other example use case is that the checker can go through all the test files and validate if the test is being run in CI, right? It can...
Oh, that's pretty cool.
Yeah, it can find all the dead tests for developers to either remove them or to hook them back up in CI. Today, a lot of tests are being disabled left and right, and we have very little visibility into what have not been running in CI. right? So information like this is extremely useful and valuable, but we have very little visibility into things like that today. Even code coverage report cannot reveal a problem like this. Code coverage will just tell you your code coverage in your production code, but it doesn't tell you what tests are being skipped. So this checker framework is supposed to open up opportunities to add more code analysis so that we can have better visibility and insight into Istio code base and maintain better code health.
Can I ask a question?
Yes.
Would it be possible to actually use this to list tests that we can run on a specific environment?
Yes. Yeah. So basically, you can implement any check and go through the source tree and
say, okay, so if I just want to run unit test, I can have this thing list all the unit tests.
Right. So
Yeah.
yes, you can use this to list all unit tests, but in order to run unit tests, you don't necessarily need to list them, right? Because we are going to, so what I'm going to talk next is the test categorization. So if you have better categorization, you should be able to just run make tests or go tests with certain parameters. And also, it's important to know that this framework is not restricted to processing test code, right? It can go through production Go files as well. So if you want any specific analysis on our Go files, we can use this as well. Any question about the general design?
So for the production code, what kind of check, as an example, could run?
Well, for example, if we know that certain, if you want to discourage certain anti-pattern, right, we can certainly write some code to define it and hook it up in linter.
So is a question about design, is it possible to write a checker that is sort of cross multiple Go files, right? Like analyzes large applications rather than just files.
Right. So for now, there's no state sharing or context sharing between different rules, but that can certainly be added. So
you could also maybe so like a single rule could have its own state, right? But it would need to know when kind of everything is passed to it so it can go and compute.
Right. So it will, I think it's most likely a rules dependency problem that we want to execute the rules in certain order and having a shared state across different rules should be able to solve it, unless we have circular dependency across different rules. Any other questions? Okay. So as for the applications, the first candidate we have identified is a linter. And we want to implement a linter based on this design and apply different linter rules to the test files according to their test categories. Right. And the test categories are, we derive the test categories based on the file path and the file names. And this linter can run as part of the Istio pre-submit linter check. Whitelisting will be allowed to temporarily tolerate some breaking rules, or if some files should opt out certain checks, it can be done through some PR approval. So for end-to-end test or underscore test files in end-to-end directory hierarchy are considered as end-to-end test. So as an example, the Istio test end-to-end test simple test is considered as an end-to-end test because it belongs to an end-to-end test, end-to-end directory hierarchy. Right. The rules we want to enforce is that all skip tests must be associated with a GitHub issue, and then the test should be skipped if testing.short is evaluated to be true. Right. So this is actually coming from the standard Golang testing doc. And SAP, as you asked earlier, right? If you have something like this, you can actually do go test dash short, and it will automatically skip this end-to-end test. So the requirement is on end-to-end test and perhaps even integration test, so that we don't need to do anything special for unit test, which is supposed to be the majority here. Right? We should have a lot more unit tests compared with end-to-end test. And we just want to put this additional restriction or enforcement in end-to-end test.
Yeah, that will reduce a bunch of the shell script and make file that basically that's this, right?
Yes, that's the goal as well. Because the makefile today is pretty difficult to understand due to the complexity and all the duplication. Okay. And the second category is integration test. So all Go test files in the integration test hierarchy, or with the underscore int integ underscore test.go suffix, are considered as integration test. Because for integration test, there are two typical requirements. Number one is to be able to put integration tests in the same package, so that the integration test can use all the package provided methods and variables. Right? Not all integration tests are in separate integration test hierarchy. And typically, the integration test in a separate file hierarchy is because they need to take advantage of the custom test main functions. Right? For those that do not have this requirement, they can be in the same package. And we want to add this distinction for both developers and automation to tell if a test is an integration test. Right. As an example, so HDO test, integration test. This one doesn't exist. I just made it up. But anything that any test files under the integration file hierarchy is considered as an integration test.
You might want to remove the S, right? Yeah.
Come again?
It's simple test.go.
Yeah, it doesn't exist. I just made it up.
No, but I thought it was test.go and you have tests.go.
Oh, right. Yes. Simple test. All right.
My feedback on that.
Thank you. And then so this one in the mixer package, right? There can be both integration test and unit test, but the integration test will have to be identified by a special suffix. So the rules we want to enforce are, so this is actually the common one. All the skip tests must be associated with a GitHub issue. And the second one is a little bit more controversial because some of the integration tests are pretty short running as well. So
when you do whitelist, can you whitelist directly in the file, or do you have to have a specific file for whitelisting?
Right. So right now the whitelisting cannot be done in the individual test file. The whitelist. So the whitelist is maintained in the tracker package today. And OWASP is implementing an integration test framework which provide some generic labeling mechanism. So you can actually label tests. You can actually label tests using any label that you want. It's sort of like annotation to your test file. Right. So once that is available, we can actually take advantage of it for to use special labels for the whitelisting. But as of today, yeah, all the whitelist is maintained in a
But then you have to create
centralized
a
manner.
rule for the whitelisting as well, right? Because people are going to abuse the annotation.
Right, but at least the change will have to be reviewed by somebody else, right?
Well, it's the same as the skip one.
Same as the skip.
When you disable, well, actually, if you disable the test with the GitHub UI, then you kind of don't need approval, right? If you have an admin, you can do it. But if you make a test, if you skip a test, you still need a review, and those still go through, right?
Yes. Well, yes, if the reviewers do not care. Yes. So yeah, there are pros and cons, right? Cons. If it's a central whitelist, then we have control. So I guess we actually will evaluate the existing integration test and see if this particular one makes sense.
And for the GitHub issue, do you need a specific format for the issue so you can?
It can just be a URL to the issue.
Oh, and you give that into the
to skip message. And then as for unit test, all the test files that are not integration tests and end-to-end tests are considered as unit tests, right? Most tests are supposed to be in this category. So the rules, what we want to enforce is, so this is a common run again, or the skip test must be associated with GitHub issue, and a unit test must not fork a new process. That's not what a unit test is supposed to be doing. Also, unit tests are not supposed to sleep as well, because unit tests are supposed to finish very quickly. There's no reason why it should sleep, except that I heard people want this in unit tests as well. So maybe we can relax it to say you cannot sleep for more than.
What was the argument for sleeping?
To wait for certain events to happen.
Shouldn't use a channel or a. Right.
Yeah. Yes. So the test should be either the code should change to expose more information so that the test shouldn't need to sleep.
Yeah. So code smell.
Right.
Yeah.
But
code smell.
Code smell.
Yeah. Is that how we call it inside, or is it just a?
That's a general term for
popular term.
Smelly code. Something's funny. It smells a little awful. It's got to sleep in a test. Sleep is generally lead to flakiness, right? Like a sleep in a test means it's going to flake when something weird happens. It's guaranteed, or as close to guaranteed as the inverse of.
And yeah, it's one of the reasons why our tests are so flaky.
Probably.
Yeah, a lot of sleep, especially in end-to-end tests today. So the goal is to disallow sleep, but I guess we will see.
Yeah, I would start disallow any unit tests.
Yeah. Send
them to me.
Okay.
And then let's work on disallowing them at other levels, integration tests.
Okay. Yeah, but in the very beginning, I suppose some files will have to be whitelisted until they are fixed. Right.
Actually, I guess in like end-to-end tests, you often do like sleep and then check a port to see if something's ready, and then sleep and then check it again. So I don't know, actually know if you can avoid that. Anyway, sorry.
So, but for unit tests, I think
unit tests
we should get rid of it.
Anything that starts a server, it's sometimes hard to avoid a sleep.
Especially for end-to-end tests, you may not be able to get to the internal state information for different server processes.
But then for those tests, so instead of using sleep directly, you could call a specific method that it's going to time out on a proper.
Yeah, so we could add helpers that do the things you need to do the sleep, and then you can.
And that way, if you interrupt or something,
Right. Yeah. So I guess there are always ways to cheat linter as well, right? You can write a different function which internally calls sleep and call that function instead of sleep. But I'm hoping issue developers are better than that. And since the tracker is extensible, right? So new rules can be added fairly easily when we identify new requirements. And hopefully I'm asking everyone to generate ideas, especially if you have problem with testing or running tests. If you have any ideas, anything that you want to check, feel free to talk to us or feel free to add to this framework directly.
I think more generally, anything, looking ahead to your next item, anything you want to report about the code base.
Right. Yes.
It's not necessarily just something you're checking. It can be any metric you want to gather out of the code base that requires analyzing ASTs.
Yes, which is the next application. The reporting cron job can be created to periodically run checks against test files similar to the linter. And it can populate the test quality dashboard. We have a dashboard already on Battledrum, but we don't necessarily have any test quality dashboard right now. But something like this will be very cool and useful. And the reporting job can even alert on call if anything is out of whack. But unlike the Go linter, the cron job can actually take a few steps further and integrate with external systems like GitHub. Like for the skip test check, it can actually query GitHub and see if the underlying issue has been resolved. If the issue has been resolved, then the test should be restored, right? It can actually generate a report and alert developers, probably the same guy who disabled the test or the co-owner, to restore the test. And similarly, the job can query CI to find out all the dead tests and stale tests, right? Meaning the tests that exist only in the source tree, but they are not seen by CI. So a lot more use cases can be done using a framework like this. And I suppose this reporting cron job is a separate project altogether. And we are hoping to improve testing telemetry as part of SWOT team as well. So we can probably brainstorm additional ideas what we can done what we want to collect specifically around testing. But as we already discussed earlier, this framework can be used to analyze even Go files, production code. So if you have any requirements that you want to implement, or if you want to query certain things in the source code, you can actually hook up with this framework and implement your own check.
That's cool.
Any question?
Yeah, this might be something we'll also present to the Kubernetes team. They're probably going to be interested in that.
Okay, sure. Yeah, and
well, us first, obviously. Starting to implement some new cool stuff.
Right. And a lot of credit goes to Jimmy, who did a lot of experiment and prototyping. Thank you very much.
Thank you.
Okay, going back to the agenda. Oh, so if you have any feedback, question, feel free to comment in the doc directly. And the doc is linked from the agenda. All right, anything else? Anyone? Okay, thank you very much. See you next week.
Thank you. Bye-bye.
Bye.